Hello Algebra 2 students, welcome to part 2 of section 11-1 graphs of sine and cosine. Sine and cosine functions can be used to model real-life phenomena such as sound waves. Different sounds create different waves. One way to distinguish sounds is to measure the frequency. In this problem, in this sound application, you're going to learn how to use this beautiful formula in order to calculate the frequency of a sound wave. Take this example. Use a sine function. So guys, we're using the sine function to graph the sound wave with a period 0.002. So the period of that sound wave p equals 0.002 with an amplitude of 3 centimeters. Guys, that is a equals 3 centimeters. And you know guys, the amplitude has an effect of the range of that sound wave. So the range gonna be at minimum -3 and at maximum 3. So I expect to see the whole graph between -3 and 3. Now guys, we can start our graph. Since we know the period is 0.002, so I expect to see a point at 0, 0. We know the sine function. The sine function always starts at 0, 0, and the end of that period is 0.002, the length of that cycle. And at the middle, at the point in the middle, I expect to see x-intercept. Between the first 2 points, there is a peak on the maximum 3. And between the last 2 points, there is a bottom peak at -3. If we connect these 5 points, we will get approximate image of the graph of this sound wave. It's a sine graph. It's a sine graph. So guys, you can imagine that the graph continues forever if you want to extend that graph. And now, how can we measure the frequency? How can we calculate the frequency? We have a formula. Frequency of any wave is equal to 1 over the period of this wave. 1 over the period. Since we given the period is equal to 0.002, if you put all of that in the calculator, you will get 500 hertz. We can combine all transformation of trigonometric function in one formula. Guys, look at this formula. You're familiar with A and B, but I think this is the first time to see H and K, but you know from your previous study what are H and K. Let's revise A and B at the beginning. A is called the amplitude of the trigonometric function, and it has an effect on vertical stretch or vertical compression. B, this coefficient in front of x affects the horizontal stretch or compression, and it also affects the period, the length of the cycle. This H is called horizontal shift or phase shift, and this added constant is called vertical shift. If this constant is positive, it's up. If this constant is negative, it's down. If this H is negative, it's shift to the right. If this H is positive quantity, it's shift to the left. Let's see how can we use this formula to apply different transformation of a trigonometric function. Using f of x equals cosine x. This is my parent trigonometric function. I'm going to use it as a guide to graph g of x equals cosine x minus pi over 2 plus 2. If you look carefully to the function g of x, guys, you will find there are 2 types of transformation. There is added number outside, and that added number represents a vertical translation 2 units up for the whole graph. Guys, imagine the midline x-axis is shifted up 2 units. So we will have the graph of this cosine function around this line. This horizontal line going to be the midline of the graph. Also, there is another type of transformation is happening. There is a horizontal shift or phase shift pi over 2. We need these important characteristics before we start graphing our g of x. Guys, the amplitude is the number in front of cosine, and it's 1. the range gonna be affected by this vertical translation. Basically, the range is from -1 to 1, but because of the whole graph is shifted up 2 units, I have to add 2 units to the minimum, and I have to add 2 units to the maximum of the parent function. So the range of that function gonna be -1 plus 2 simplifies 1, and 1 plus 2 simplifies 3. So I expect to see the whole graph is between 1 and 3. So 1 gonna be the minimum and 3 gonna be the maximum. The period of that function is determined by the formula 2 pi over the absolute value of b. B is the coefficient of x, and it's 1 in this situation, so it's gonna be 2 pi over 1 simplifies 2 pi. So the period is just like the parent cosine function 2 pi. Phase shift. Guys, we can get the phase shift by equal whatever inside this parenthesis to 0 and solve this simple equation. So if x minus pi over 2 equals 0, it means x equals pi over 2. So there is a phase shift, there is a horizontal shift, pi over 2 units to the right. Now we have the most important characteristic that allows us to start graphing this function. Guys, I recommend to start graphing the parent function as a guide. It's going to be much easier. So we know the graph of the parent cosine function f of x equals cosine x. It starts from 0 and 1. This is a start point. It has x-intercept at pi over 2. And it has another x-intercept at 3 pi over 2. It has a bottom peak at pi and -1, and it has a top peak at 2 pi and 1 this way. If we connect these guys, we will get the graph. Also, we can continue, guys. If we continue, we can continue graphing this. So there is another x-intercept is here, but one round is enough. So if we connect these points, we will have the graph of the parent cosine function. That's the parent of the graph of the parent cosine function. Now guys, let me choose a different color in order to graph g of x. G of x is shifted up 2 units and is shifted to the right pi over 2 units. So guys, we can perform this in the critical points, the 5 critical points of the parent function. We have 1, 2, 3, 4, 5. That's the end of one period, so that's enough, guys. So imagine, guys, if you move this point at 1, 2 units up, it's going to be at 3, and you shift it to the right pi over 2, so this point going to be at this position. The second critical point is that point. If we take this point 2 units up and we move it 1 unit to the right, also if we take this bottom and we move it 2 units and 1 unit to the right, this point 2 units and 1 unit to the right. Let me double check if everything is okay. Yes, it's gonna be fine. And finally this point gonna be shifted up 2 units and 1 unit to the right. And also if you want to apply this for the extra point, 2 points and 1 unit to the right. So guys, if I connect this, I will have approximate image of the graph of g of x. Let me grab that. And the graph continues and the pattern continues forever. Guys, we have a question. It says identify the maximum and the minimum values. The maximum, we know that the maximum value is 3 and the minimum values is 1, but we need to identify the maximum occur at what and the minimums occur at what. Guys, where is the maximum and the minimum of the graph of the red graph g of x? The maximum, this point is considered a maximum, this point is considered a maximum. So the maximum occurs after one period, and the start point is at pi over 2, so the maximum occurs at pi over 2. And if you add one period 2 pi to this, you will get 5 pi over 2. This is exactly the second maximum, 5 pi over 2, and you can continue that by adding 2 pi all the time. What about the minimum? The minimum occurs at this point, guys. That is the minimum. It occurs at 3 pi over 2, 3 pi over 2. And if you add one period 2 pi, it means 4 over 2, so it's going to be 7 pi over 2, and so on. You continue adding a complete period in order to get the minimum occurs at what x values. Pretty nice. Let's finish this section, guys, with employment application. The number of people in thousand employed in a resort town can be modeled by this trigonometric sine function. A lot of types of transformation are happening, where x is the month of the year. So when you represent your graph, you put the month on the x-axis. So 12 months on the year. Make sure you have enough coordinate plane in order to display all information. A couple of things are needed in this employment application, guys. We need to graph the number of people employed in the town for one complete period. So we need to create the graph that represents this trigonometric function. Later we need to answer one question. We need to start with the important characteristic of this function. Guys, let's start with the amplitude. The amplitude of that function is going to be 1.5. 1.5 is the amplitude of that function. The phase shift, we can get the phase shift by equal x plus 2 to 0 outside. If you equal x plus 2 to 0 and solve this equation, you will get the phase shift 2 units to the left. Guys, it's time. So it means 2 months to the left, the whole graph gonna be shifted. Yeah, maybe it's the previous year. So don't take it it's a math error and say time cannot be negative. We can consider this is the current year and this is the previous year. So there is a phase shift -2 of that graph 2 units to the left. Period. How do we determine the period of that? You know the formula, guys. It's always 2 pi over the absolute value of b. So it's gonna be 2 pi over, what is the absolute value of b? B is the coefficient in front of x, and it's pi over 6. If you simplify that, you can cross this 2 with this 2. This is not 2 over 6, this is 2 over 1 over 6. That's gonna be 12 months. So the period of this function, this trigonometric function, is gonna be 1 year or 12 months. The range of that function, guys, is determined by couple of things. It's determined by the amount of the amplitude and the vertical shift. So what is the range of the parent cosine function? The range of the parent cosine function starts at -1. This is the minimum, and stops at 1. Am I right, guys? But the whole thing is multiplied by 1.5 outside and is added to 5.2. So we need to add 5.2 to the start point, and we need to add 5.2 to the maximum point. Guys, now we can get the range of that function. If you calculate that, guys, -1 plus 5.1 multiplied by 1.5 and 1 plus 5.2 multiplied 1.5 outside, that's gonna be 3.7 and 6.7. 3.7 and 6.7. Remember, guys, when you graph this function, you need to start with the midline. The whole graph is shifted 5.2 units to the top. So almost above the 5, we have the midline of this function. It's going to be horizontal line this way, and the function is centered around this line, this horizontal line. Minimum and maximum are very important at the beginning. The minimum occurs at 3.7, so this point, and 6.7, that's almost right here. So I expect all the values to be between this value and this value. The parent sine function is a good guide for us, guys. So if you want to start with graphing this function, it's going to be a good idea. Or if you want to start with graphing this function directly, you can start with this function. We know that the graph of that function occurs at the maximum, so but there is a vertical shift 2 units to the left, sorry, horizontal shift 2 units to the left. So the start point gonna be 2 units to the left. It's gonna be somewhere right here. Let me start with the parent function better, guys. or no need, we can just continue graphing that, guys. We know that the complete period is 12 months, so if you divide this 12 months by 4, you will get a 12 over 4. It's gonna be 3. So every 3 months you should see a critical point. So the first critical point occurs at 2 months to the left. So 3 months from here at this, you should see a x-intercept. So this is gonna be another point. And 3 months later, 1, 2, 3, and when you go down to the minimum, you should see another point right here. 3 months later, 1, 2, 3, you're gonna see another x-intercept. So the graph of the function is gonna be something like that, guys. It's gonna be like that. What is the maximum number of people employed? The maximum number occurs at the maximum value, which is 6.7. Remember, guys, the number of the population is in thousands, so it's 6.7 multiplied by 1000 is equal to 6,700 person. Thank you very much. Practice well and see you in the next section. Bye.